We are here today with physicist Thomas W. Campbell, author of My Big Toe, a scientific big theory of everything that delivers a major scientific conceptual breakthrough and bridges quantum mechanics and relativity. Tom is a former large complex systems analyst with NASA and is currently a consultant for the agency. Tom is also a consciousness researcher within the large complex system we call reality. He has held both of these jobs simultaneously for the past 40 years and has conducted many experiments in both fields. Tom, this is not new news for you, but controversy is brewing in the science world, the material science world at least. When Dr. Rupert Sheldrake was approached by TEDx Talks to give a talk within the theme Challenging Existing Paradigms, he graciously accepted, since it fit perfectly with the findings set out in his book, Science Set Free, also known as the Science Delusion in the UK. In the TEDx talk, Dr. Sheldrake set out and challenged 10 dogmas of science. Apparently, however, the talk was too much of a challenge to existing paradigms because TEDx Talks was pressured into removing it from their mainstream offerings and tucked it away in a blog, or as Dr. Sheldrake calls it, the naughty corner. For this interview today, we will be discussing Dr. Sheldrake's 10 Dogmas of Science. Tom, your book, My Big Toe, written in a trilogy format, also leaves dogma in the dust. So discussing these 10 points should be supportive of Dr. Sheldrake's findings. If you would like to comment on anything first, that would be great. Then we will start with dogma number 1, which is nature is mechanical. Tom?
Yes, it's a shame that the TED Talks organization has decided to censor scientific ideas according to existing dogma, existing scientific beliefs. How are you ever going to get ahead if you're not allowed to talk about anything new? It's like, well, okay, we're the TED Talks, and as long as you talk about what we believe is true right now, then you can talk. Well, that means we'll never know anything much more than what we think is true right now. How do where's the breakthrough? Where's the new information? Where's the possibility of learning and growth and expanding your science if you limit what you can talk about to the things that you already know? Already think you know, to the dogmas that are and the beliefs that basically are blinding you to anything new. So it's a real shame. Like you say, TED Talks were supposed to be kind of an outreach program. Reach out there and get those big ideas, those things that are going to help us change and grow our science to something more than it is now. It was that sort of a idea to begin with, and instead it's turned into we can't talk about anything that the that the guard dogmas don't want don't want to talk about. They're guarding the status quo. This is what I believe, this is the way I think it works, and if you think differently, then obviously you don't know, and if you don't know, then you can't come on our TED Talks. So we have that kind of that kind of attitude is very anti-science. That's against the scientific idea of open inquiry. It's right. Open inquiry as long as you agree with my beliefs. As soon as you step outside scientific dogma and scientific beliefs of today, then we don't want to hear about it. That's pseudoscience. That's not real science because we know all the science there is, and if we don't agree with you, then obviously it's not right. That is antithetical to science. That's not science at all. That's theology is what it is. I mean, maybe I shouldn't say that. I give theology a bad name that way, but that's basically belief in its worst form. Belief that brooks no difference, that brooks no challenge. Well, if you can't challenge the status quo in science, gee, where should you be able to challenge the status quo?
Exactly Dr. Rupert Sheldrake's point. I think there was also another banned or downgraded to blog talk. That was by, I think it's Graham Hancock. And it was War on Consciousness. Now, I haven't had a chance to fully delve into that yet. But I think the interesting point here that is upsetting people is the word consciousness. And as far as TED Talks go, not to defend them, but they received outside pressure from skeptics. It seems this word consciousness, which is one of your foundations, you say consciousness is the computer when you are referring to Dr. Fredkin's work as well. This seems to be the scary word in science.
Well,
And
yeah.
I think it's about time they got over this.
Yes, I think it's about time they got over it too. The problem for them is that, the traditional view, which is mainly a deterministic view, says that the brain creates consciousness. And those who study consciousness have come to the conclusion that there's no way to prove that. There's really no way that you can scientifically come to that conclusion or make that statement that the brain produces consciousness. And in the study of consciousness, they call that the hard problem. The hard problem is really hard because it's impossible. You see, the hard problem is how do you take matter? How do you take gray matter, biological stuff, electrical impulses, neurons? How do you take all of this stuff that's built up, of course, out of inorganic matter? All of the gray matter is built up of things that come out of the periodic table. Plus we have enzymes and other things which are complicated things that come out of the periodic table. So you have basically an inorganic world, which is all the elements that we have, all inorganic. Out of that you build up an organic world, and this organic world produces consciousness. And the hard problem is, how does it do that? How does this brain actually create consciousness? Because when you look at all the attributes of consciousness and what it's doing and so on, it's a hard problem to justify how the brain could do that. So this hard problem of consciousness, so-called, is a really hard problem because the brain doesn't create consciousness. So trying to show that it does is a very hard problem because, you'll never solve that problem and because it's the wrong problem. And the consciousness researchers have kind of gotten there. Many of them are saying that we'll never be able to solve that problem. They see there is this unbridgeable gap between matter and thought, and they just don't know how matter can create thought. You see, that's their issue. Well, even though science says there isn't any connection here, guys, that we have any really hard information on, scientists in general want to believe that the brain creates consciousness, because that way they don't have to deal with the world any bigger than the material world. You see, the material world is all there is. That's a fundamental belief of science. There is nothing other than the material world, which means consciousness has to be a product of, created by, the material world. As soon as you let that one go, as soon as you say consciousness is created by something other than the material world, suddenly you've opened up the floodgates to all sorts of other things, and the scientists don't want to go there. So that's why this consciousness thing is such a big deal. It's like that's the line drawn in the sand. If they give that up, that consciousness doesn't have a material cause, then they've opened the doors to lots of things that they just don't want to deal with, that they're not equipped to deal with, and that they know nothing about. And that's the scary part for them. So that's why when you talk about consciousness, you have, a set of, the old guard dogmas, or the old dogma guards, or however you want to say, the old guard that has a strong belief, which we call dogma, about the way the world works. Everything is based on material causes. So once science gets to the point that they say, well, guys, it just doesn't look like we can ever justify consciousness being based on material causes. How do material things cause thought? You see, it's a hard problem. Well, okay, rather than saying, well, when you get to the point that it just doesn't look like it's right, but you really want it to be right anyway, instead of confessing that it's just not right, you say, well, it's a hard problem. You say, you try to justify it and calling it a hard problem, and we'll solve it someday, but let's right now not think about it. Let's go on. So that's where we are as far as science and consciousness. They don't want to take that step because they'll no longer qualify as the kind of leaders in our culture that know what's going on. They'll no longer qualify as the high priests of Western culture if there's a whole lot of things that are important. Consciousness is a pretty big idea, right? That's it's not like a little thing out on the edge. That's just as big as it can be, and that will kind of take them out of that game, out of that idea that everything is physical. It'll blow up their world. So that's why. You ask, why is it about consciousnness? Why is it if anybody gets up and says anything intelligent about consciousness, scientists, get upset. The skeptics start to, fly around like, buzzards. That's the reason. That's the reason why. But now,
well, Tom, we've discussed this before, and you have said that there is plenty of valid purpose for material science. What would be so bad about accepting simply a larger viewpoint?
Well, what's so bad from the view of the traditional scientists accepting a larger viewpoint is that larger viewpoint completely undermines everything that they have believed in and worked for, over the last, 3 centuries since science actually became science. You see, before science really was an ongoing thing, or was really a body that was called science. You had individuals like Copernicus and Galileo, and these people said, hey, I've collected data, I've done experiments, and I see that things work differently than what, in that case, the church says that it works. You see, they were running against the high priests of the church at that time. And what happened is that they were told to sit down and be quiet. You keep saying these heretical things and you will be burned at the stake, etc. So science has tried very hard to get away from anything other than material cause. Take the data, do the experiment, and report on the material causation. And that's what they've stuck with, because they don't want to go to a place where the causation is non-material. See, that's back where the church was, right? They were non-material causes for everything. God does it, the angels do it, and so on. And they wanted to get away from that where it's belief-based, and they wanted to get to science-based. They wanted to get to material-based. That was the difference. So their whole concept of reality has been based in this material fact versus belief sort of thing. And they've got this feeling that if you ever get away from that, if you ever admit that there's something in reality that's larger than just material reality, that they will lose everything they've worked for, that we'll go back to the high priests running things, that suddenly belief and things in the non-physical, this is stuff you can't measure. You can't measure things other than physical things. So it's kind of opening that door back to the bad old days when everything wasn't based on material fact. All right, consciousness isn't material. You see, it goes in the category of non-physical. It's outside of our physical universe. This is a virtual reality, and as Fredkin said, a virtual reality can't, produce itself. It has to come from other, which is outside of this reality. Well, that means it's not physical. Now here I'm defining physical as everything that's in our physical universe. It's not physical. It's outside. Our physical universe is a virtual reality created in other, created elsewhere by other. You see, now we're out of the physical. You can't measure it. Science has nothing to say about that, and they fear it. They dread it because they see it, back in the days when belief ruled everything, mostly religious belief ruled everything with an iron hand. Well, now we have scientific belief ruling everything with an iron hand. You see, and one is just about as obnoxious as the other. If you don't have an open mind, if you can't let new information in, then you're stuck. And whether you're stuck at religious belief or stuck at scientific belief, you're still stuck. Now, we might all agree that being stuck with scientific belief has been a better thing because we stopped burning people at stakes and we now, talk over Skype and we record things on electronic devices, and all of that has kind of come out of science. So science has delivered wonderfully on their promise of a more rational world. On the other hand, it's time to move on. Now we have to go beyond that. The next bigger step is to understand consciousness, understand our origin, understand, what was before that Big Bang, when there was no physical universe. How did that little spot of energy and high pressure and temperature and all that we call the Big Bang, how did that come to be? We need to go further. We need to understand things. Why is it that particles are probability distributions? Why is it that things can become entangled? And, how does all this happen? That doesn't happen in a physical world, that's something else going on there. How does the placebo effect work? How can you tell somebody something and make their body react to that? The body's a physical thing. What is it about this mind-matter connection? How is it that Pear Labs can do all this research in mind-matter interaction and intent of a developed mind can affect physical outcome? So all of these things are real things. And if physics and science in general just keeps their head in the sand and says, oh no, that's too scary, we don't want to do that. Well, they're just, they are limiting where we can go. Now, no, we don't want to go back to the point where belief rules everything. That's not the thing. It's not that way. The choice is not everything's derived from physical matter, materialistic viewpoint, or the religious high priest will have us all burning at stakes if we disagree with them, and we'll be back to that kind of terrible world that we lived in back in 1500s, and so on. We don't want to go back there either, but that's not the choice. We don't have to go back there. We can see this larger reality in terms of science. It doesn't have to be about belief. You see, that's what the My Big Toe is. It's a scientific model of the larger reality, which includes consciousness, and it is science. So it's not you don't have to have, if we leave this idea of materialism, we regress back to what we had in the 1500s. Well, that's not the case. We move on with a bigger scientific viewpoint that expresses physics, quantum mechanics, and relativity as a subset, as a smaller subset of a bigger picture. And your science grows. So that's why the scientists are afraid of losing everything that they've gained since, Galileo. And now they're in charge. See, they have high status. They're the high priests of Western culture. They tell us what we should think, what we should believe. When the scientists say that's true, then we think it's true. We believe it because scientists tell us the truth, right? They've got this scientific method. It's not somebody's belief that they think it's true and then they're going to get everybody who disagrees with them. Well, but it's kind of turning to that, right? Now we have scientists thinking something's true and they're getting people that disagree with them. Now, how does that differ from what, the persecution of Galileo? You see, it's all the same thing. So now the scientists are the high priests. They have the dogma and the belief, and they want to get people and shut them up, the heretics, like Rupert Sheldrake, who say, guys, I see a bigger picture here, and I've got scientific evidence for this picture. And, now they don't get Rupert and try to burn him at the stake, but they do pull him off of TED Talks so that he has no voice. And without a voice, then nobody hears him. And if nobody hears him, then it doesn't affect,
he's
the big
still
picture.
There. He is on the blog, but it's an unofficial sort of stand that they capitulated to. With Galileo, he was excommunicated by the church, I believe this is the right one, and then subsequently, rather recently, pardoned. So perhaps there's hope.
Yes. Well, he also was a what do you call it when you're not really in a jail but you're restricted just the same? House arrest. Galileo was under house arrest, I think, for a long time. He was limited in what he could do and what he could say. No, he didn't get burnt, but he wasn't really allowed to be free and say what he thought either. So he was reined in. And that's what they're trying to do with Rupert. They're trying to rein him in to minimize his effect, his heresy, his scientific heresy. So it's back to the history. Yeah, it's back to the same thing. And see, that's the problem here. They need to go on. They need to understand consciousness. And they need to see the bigger picture. And they need to see that if you have this scientific bigger picture, then science is jumped forward. It's a big leap forward for science because there's all kinds of things in science now that are pointing to reality is information. Experiment after experiment comes up with, the best way we can describe reality is as information. And with this larger picture, then we see that indeed that's true. And the double slit experiments, entanglement, the paralabs work, all these other things start making sense. Now there's good scientific explanation for things that are now called beyond normal, paranormal, you see. And paranormal just means not normal, beyond normal. Well, hey, relativity was paranormal, right? It was beyond normal back before, relativity became normal, and the first people who looked at it and saw Einstein's theory, they kind of shook their heads and said, that's nonsense, that doesn't make any sense. Okay, good mathematics, but, the interpretation's wrong. So that's the thing is, we have to be open and expand and keep growing the science. Otherwise, we turn into the very thing that science was created to stop, to avoid. And that's the problem. So this, these old guards, old dogs that are guarding, the status quo in science, they need to realize that they are now the high priests, and they are trying to censor new ideas that violate their beliefs. They're now trying to determine who are the heretics and keep them quiet. That's what science was created to avoid, and now science has become it. That's the problem. But it's not all science. There's just some trolls, that are guarding that bridge. All science is not like that. They're just some, but obviously they do have some clout because they've created this problem for Rupert Sheldrake, and that says they're not inconsequential. But look around on the internet, and you'll see there's lots of scientists now talking about this reality being virtual, you see. And now things that Rupert Sheldrake's talking about make good sense in a virtual reality. So anyway, that's kind of the background of why does science get excited about this, and why there are some trolls guarding the scientific dogma, and that's it. So it's a basic gut level. We can't go there. We've been there 5 centuries ago. It was awful. We don't want to go back. But what they don't get is that we don't have to go back. We can go forward and see a bigger picture in which science is a part of that picture. But there's more than just the physical. In this virtual reality, there is the source of the virtual reality, which cannot be physical. And that source, by the way, is consciousness. So that's kind of a little history, roundup about why is there all this angst about consciousness.
That's right. Thank you for those comments, Tom. Shall we start one by one with the 10 dogmas of science?
Well, sure. Let's do that.
Nature is mechanical. Nature is mechanical.
Yes. Now,
that is his first dogma.
Yeah. Now that idea began in earnest with Newton. That's the Newtonian worldview. Newton said, look, we can break all this down to mass and force, momenta, acceleration, all the basic things, time, and after that we can just calculate how the world would be. And in Newton's time, well, it was really after Newton. This is kind of mostly the scientists came after Newton. We shouldn't really blame this on Newton. He was just the guy who started it off with some very ingenious work, pulling a lot of things together, But those that came after him saw the world as a big clock. That's what he means, mechanical, like a big clockwork. And the idea was that if you knew the state, and we should say state vector, well, what that means is, mass, position, velocity, time of every particle in the universe, then you knew everything. After that, you could compute everything that would happen from that time forward if you had all this basic information in science. It was just a big clockwork. If you know how the inside of your clock works, you can tell where it's been and where it's going because it's just a big machine. And that was the Newtonian idea. Well, the Newtonian idea held for a long time. It held for a long enough time that scientists, on all kinds of scientists, but I'll blame it on physicists most because that's kind of the basic, most fundamental science. Physicists got the idea that this is a big machine, and that everything is a big machine. Bodies, biology, it's just a big machine. If you know how things work, then you can predict what's going to happen next. The only reason we can't predict everything is we don't have all the initial conditions, and we don't necessarily have all the facts as far as how things interact. Well, when relativity came along, that just kind of blew this big mechanical view of reality away. Because relativity said, no, it's not necessarily, a great big machine. There's things that, a lot of it is relative to the observer's viewpoint. And he started talking about have different observers in inertial frames traveling at velocities relative to each other, and suddenly the world looks different. We have time dilation and length contraction, and mass grows with velocity and so on, and these things are not at all part of this big mechanical world. And then it got worse when quantum mechanics came along. Okay, so relativity made this big mechanical reality a very strange and weird mechanical reality that kind of depended on the observer's viewpoint. And then quantum mechanics came along and said, well, this machine is not even a physical, not even a real solid massy machine. Particles are probability distributions. If we think of particles as a probability distribution, then we can compute what happens next but otherwise we can't. So suddenly this fundamental idea that at the particle level, it's just probability. It's not really little massy particles. And these days, physicists say things like this: an electron is a point that has the properties of charge and the properties of mass. They don't say an electron is a little chunk of mass with charge. That's what they used to say. But now it's a point, and it has the properties of mass and the properties of charge. Well, how would you simulate an electron in a computer? How would you simulate it? It would be a point with the properties of charge and the properties of mass. Well, that tells you, that points to the fact that reality is virtual. It's information. A simulated reality is a reality created out of information. And that seems to be what we've got. That's where science is taking us. So this idea that nature is a big machine is a Newtonian concept that we just haven't been able to shake. Scientists and science got so convinced of that, they bought into so completely the idea of reality as a big machine, that even though we're almost 100 years past relativity and quantum mechanics, not quite, it's like 87 or 88, we're in around 90 years past those major sciences that showed that it isn't a big machine. Most all scientists, including physicists, still down at their gut level, in their hearts, they still see it as a big machine. And it's all physical, even though physical particles aren't really physical anymore. They're probability distributions. So that idea is still there. Our mindset today is reality is a big machine. Everything's based on material, you see, and that's just a holdover from Newtonian physics. We've never really accepted quantum mechanics for what it is. What have we done? Well, here's quantum mechanics, and it kind of denies that reality is a big machine. So what have we done? We say, well, reality really is still a big machine. We just don't understand this quantum mechanics. This quantum mechanics is just weird. And you can't really, say that quantum mechanics, means anything. We just don't know what it means. So what they've done is they've taken the science that contradicts their belief, and instead of changing their belief, they just call that science weird science that nobody will ever understand. You see, there's a problem there. So they cling to the Newtonian viewpoint, and their science that conflicts with that viewpoint, they write off as, well, we just don't understand it. Well, we don't understand it in any kind of normal way, and normal means materialistic way. You see? So we can't understand, and that's a quote, right out of Feynman. Feynman, one of the best quantum mechanics theorists ever, a brilliant guy, and he says, we probably will never understand quantum mechanics, in the normal sense of understand. Well, that means in a materialistic way. Well, of course you won't. Quantum mechanics says reality isn't material, so you'll never understand it, in a material way. Well, guys, face the facts. Reality is not material. And then let's go on and grow from that. And it's like, oh, no. Reality is all material. We just don't understand this quantum mechanics. You see, it's just weird and we don't understand it. Well, that's where we've gotten. That's why it's almost, a century past, quantum mechanics inception and relativity's inception. We're getting close to a century beyond that, and we're still stuck in a Newtonian viewpoint because we refuse to accept what we don't want to hear. That's what happens when you're trapped in a belief. Not only does it make you want to censor the heretics, it makes you refuse to see, what you don't want to see. So quantum mechanics is just this mysterious, crazy science that we'll never understand. And our reality is just all material and, just like we always, thought it was from Newton on. So it's that kind of thing. So you say, well, how can science, who, quantum mechanics isn't a new science. How can they go on with this idea that non-local phenomena don't exist when they do? Well, they just say, well, yeah, it does, sort of, but that's just craziness, and it's really material. We just don't understand it, and they go on. Obviously, you can see what's going on here, right? This is somebody who has a belief. Their science tells them it's not right, and they just deny it and call the science not understandable in any normal sense. Shut up and calculate, right? That's the deal. So yes, we believe that nature is mechanical, even though we have tons of proof that says it is not. We refuse to accept that, and we just continue on with this idea that nature is mechanical, because that makes us feel like we're in charge. That makes us feel like this crazy stuff frightens us, because it's not physical. And the physical stuff is what delivered us out of the 15th century, belief-based mania that ruled the world for so long. So that's why. Yes, that is a big one. That's probably the most underlying, the most fundamental of these dogmas. That's the one that all the rest of them kind of hang on, a refusal to not be a materialist. They don't want to leave that. There's security in materialism. There's terrifying uncertainty in something that goes beyond materialism.
Well, thank you, Tom. The second one is matter is unconscious. There is no subjectivity.
Yeah, well, when he said that, and just as that statement is made, matter is unconscious, I would agree with that. I'd say, matter is unconscious, but that's not just what he means. I watched the video just a little bit before, so I kind of got an idea of what he was talking about. Sure. And he talked about the science believes that nothing is conscious. That's really what he means by that matter is unconscious. He doesn't mean that rocks have big thoughts, and that, fence posts are watching you as you walk, down the road and then discussing you after you walk by. That's not really what he's talking about when he says, right. Matter is that, this big belief that matter is unconsciousness is unconscious is a dogma. What he means is that science believes that nothing is conscious. And as he says in his talk, they don't even believe that we are conscious. Right. Because there's this hard problem that says consciousness, there's no real material way for that to exist. Matter doesn't create thought. How does matter create thought? You see, that's the hard problem, and because they're stuck with that hard problem, then they say, well, then if matter doesn't create it, it doesn't exist. So nothing's really conscious. We're just interacting, you see. Now this gets them to their deterministic idea. There is no consciousness. There is no free will. We just are in this deterministic, right? That goes back to nature is mechanical. Reality is just the big machine. Okay, that's all deterministic. And the same determinism that nature is mechanical says that, we're just going through the motions. We have no free will. We make no choices. It just seems like we do. It's a hallucination. We kind of believe we do. We look at it and we have that illusion of choice and mind and thinking, but really, that's not happening. There is no such thing as consciousness. It's all a big machine, and it's all deterministic, and it just cranks on, and we just have this hallucination. Well, that's nonsense. It's nonsense that's been created to maintain a belief. When you have a belief and things, your belief starts to fall apart, what you do is you make things up to support your belief. And if it's nonsense, well, then you come up with nonsense. I mean, we see that all over. Find somebody that has a very fundamental belief about something, and you'll see that if you corner them with an inconsistency in that belief, they'll just make something up. So in order to help them maintain the belief, you say, well, where these dinosaur bones that are, so many million years old. Oh, well, let's see. They were planted there. People put those there trying to, rebut the truth, So they make stuff up. That's the way it is with belief. If you've got a strong belief, you make up nonsense. Well, this idea that, that nothing's conscious, we're in this deterministic world, there is no free will, there is no consciousness, everything just happens because it's meant to happen, because it's a big machine, the big clockwork, nature's mechanical. That's really, really silly, That's a really bizarre and a dumb idea. But if you're desperate and you have a belief, then you make stuff up like that, and you say it like you believe it, and you beat anybody with a stick who disagrees with you. Or actually, you just pull them off of TED Talks, and make them go sit in a corner. So that's the matter is unconscious. Okay, now there's a confusion here. There are a lot of people who say, yeah, rocks are conscious. Though I don't think that's what Rupert was trying to say. There are people who will say that. And there's a confusion. It's true, this larger conscious system, the source of the virtual reality is itself a digital information system, okay? And that's what I call consciousness. I call it the larger consciousness system, okay? Now, everything is a product of consciousness, okay? Because you have this larger consciousness system, it creates a virtual reality we call our physical universe, and everything in this virtual reality is a product of this consciousness system. So in that sense, you can say everything is a product of consciousness. Rocks and fence posts are products of consciousness in that they are created inside this virtual reality. They're information. Rocks are just information, just like our bodies are just information. The physical world is best described as information with attributes, like the electron is a point with the attribute of mass and the attribute of charge. That's the way a simulation would define an electron. Anyway, so everything's a product of consciousness. Consciousness, and another way to say that is consciousness is fundamental. It's at the root of everything else. So people take that truth, that idea, and then they say, well, if consciousness is the creator of everything, then everything is conscious. But that doesn't really work like that. Consciousness is the creator of everything, but everything is not conscious. Now, that depends a lot on how you define conscious. Okay? We can define conscious maybe in different ways that allow more or less into that definition. So you have to define consciousness and understand the difference between being conscious and being a product of consciousness. Okay, basically, in my theory, and I just wrote some definitions down, and the definition of consciousness, takes up a couple of pages, so we can't do all that. But basically, it's an awareness, with free will. It has intent. It has will. It has free will. You might say that it's sentience, and that word can be pronounced either sentient or sentient. In the dictionary, you have both pronunciations for. I say it both ways because some people say it one and some say it the other. But anyway, so it is a sentient being, that can interact. It's interactive. It has free will. It can make choices. It has a non-zero decision space. There are choices that it can make, and it's not just hardwired. It's not a machine. So I guess that's kind of the definition of consciousness is it's not a machine. It's not just hardwired, and it has choices. So in any case, rocks, I don't put rocks in the category of conscious. I don't put trees and vegetable matter, living things, all in that group of conscious either. They have to have a non-zero decision space, and they have to be able to make free will choices. They need memory, they need a processing, and there's a little more details to it than what I'm just saying. If the listener wants to see more about it, then go to YouTube. Go to YouTube, TWCJR44 on YouTube. That's the ID for my channel there. and then look at the Calgary workshop or any number of 200 or more videos that are there, and you can get a lot more detail on these ideas that I'm talking about.
Tom,
Yes.
thank you. Tom, people have done some experiments. When you mentioned trees, I was intrigued. Some have done experiments whereby they have discovered that trees can communicate with each other. They might let another tree know that it has a sort of disease and to build up their defenses. Or a cactus, for instance, was aware that it was going to be chopped down. How would you classify that, and what would you think of that?
Well, any definition, if you define consciousness as something that interacts and makes choices, and if you don't have any information that a tree interacts or makes choices, then you say it's non-conscious. If you then study a tree more closely and find out that it does indeed interact and make choices, then the tree becomes conscious. So, definitions are just definitions. What you put inside or outside the definition depends on the information you have available. Now, I would say that, and from the information that I haven't read what you just said, but from the information that I had read, which basically came back from Clive Baxter, who did a lot of experiments with plants reacting to things, I would say that plants have awareness, but that doesn't necessarily make them conscious. If they don't have a decision space, if they can't actually make decisions, then they're not conscious, under my definition, okay? But you can be aware of something, but not actually have any choices to make about it. You're just aware of it, but there's really no decisions, no choices, nothing you can do about it other than that you're aware of it. Okay, well, in that case, you're aware but not conscious, you see. So mostly I would put plants there, and Clive Baxter was measuring that awareness by putting a lie detector apparatus on plants and then doing things, threatening them, burning a leaf, killing brine shrimp, doing other things, and he saw that the plants would respond to that. Well, that's an awareness. And awareness can respond, but it's not necessarily making choices. Now, this new information that you mentioned, one plant telling another about a disease, you'd have to decide whether that was hardwired, that was just a mechanism. Okay, it puts out some sort of chemical in the soil that migrates over to the roots of the other plant. Now that plant gets a message. Well, that's not necessarily making a choice. That's just a hardwired situation, right? We have cases where they trained flatworms to go through a maze, and then they these flatworms would be able to go through the maze much more quickly to get their food or whatever it was, reason they went through the maze. And then they took some of the trained flatworms and fed them to other non-trained flatworms, and the non-trained flatworms then knew how to go through the maze, you see, by eating flatworms that had already learned it. Well, that means that the information was encoded in their cells, right? The cells had that memory, and these other worms were able to pick that memory up. So the biological world can show us all kinds of very strange and interesting phenomena, but you can say that was just hardwired. They weren't making choices in that maze. They just picked up some biochemicals that had a certain, stimulus and response, right? So they were just, they weren't making a choice. When the doctor makes you cross your legs and he hits your kneecap with a little rubber hammer and your leg jumps out, that's not because you choose to make it go out. You say, that's not a choice. That's just hardwiring. It's just the way it works. It's not a choice of yours to throw your leg out or not. So that's what I'm talking about. So if things are just hardwired, if it's just this chemical, moves over to the other system and creates a reaction, it's just stimulus response hardwiring, then there's no consciousness there. That's the way our computers are. Our computers that sit on our desk are just hardwired. right? That's including their software and everything. You know, they don't think, they don't have choices. They don't decide, well, I just don't feel like working today, so I'm not going to work. You know, you give them a certain, you know, whatever, and they will respond to it in the way that they respond. That's what I mean by hardwiring. So whether these cactus and other plants, it's just a hardwired thing or not, I don't know. And if it turns out it's not, if it turns out that it's not a hardwiring, but they are indeed communicating and making choices, then I would move them over into the conscious category. If it turns out they're not, then I wouldn't. They're aware of their environment, but okay, so you threaten a plant and the plant reacts to that threat, but what does it do? What choices can it make now relative to that, you know, to that threat, you see? And are those choices because of a conscious choice, or are they just hardwired? It's a response. Some things are really hard to tell. You know, dogs and cats and people, that's easy. They obviously make choices. You can see that going on. You know, you get to things like clams and, you know, things like that. I don't know, you know. Is it hardwired or is it not? It's really hard to tell in some cases, but if people wanted to do enough research, they could probably, you know, come to an understanding of whether they were conscious or not. I mean, it's not like it's hard to, that's that hard to do. It's just nobody has done it.
I know Rupert Sheldrake has worked a lot with animals and things, so thank you for the comments on that. The third dogma is the laws of nature are fixed. We're always the same and will always be the same. Now, I know you've discussed the speed of light, but there are other fixed laws of nature such as gravity. Could you comment on this?
Well, yes. Again, what he means here isn't that we can never find out anything new, that they're fixed. You know, it's not saying, well, we know everything. We're omniscient and know everything, and therefore it's fixed. We can't find anything new. He's not saying that. He says that basically, well, let's use one of his example. Okay, he talks about somebody measuring a crystal, and that the outcome of that measurement is uncertain if this crystal is brand new. Nobody's ever seen it before. Nobody's ever measured it or looked at it or grown one like this before. That the outcome is uncertain, but that afterwards, okay, all such crystals tend to be more or less follow the same pattern. Okay, and he talks about that in terms of a morphic field. And the first crystal didn't have any morphic field to help define it, what it should be. Therefore, it had more degrees of freedom, you might say, to grow however it did. Whereas after that, the first crystal then kind of creates this morphic field, and that other crystals of the same type then tend to be like that one because they get an identity, if you will. And he, in his talk, he talked about a giraffe as a giraffe because of the morphic field identifies giraffeness. You know, it's not just, you know, a genetic thing and all the details. Anyway, so I think these are his examples, and this is really what he was talking about, not that we know everything. And we talked about the speed of light, and in a virtual reality, you know, the speed of light can change a little bit, but it's not changing by much. It's changing by 0.1% of its value. And that has to do with the larger consciousness system who runs this virtual reality, needing the system, needing the virtual reality to have more resolution. And when it has to have more resolution, then, you know, you have to change things. The little delta T driving it, and the little delta volume, the pixel, if you will, and the 3D thing, those are going to have to change a little bit. You need the pixel to get a little smaller, more resolution. You need the time to get a little smaller. You need more time resolution. And you can do those because the ratio of those, the delta x to the delta t, defines the speed of light. So you can do those and keep the speed of light about the same. But because this is a digital system, you can't just change things to an infinite number of decimal places. You see, computers only compute to so many decimal places. And basically, integer arithmetic is a lot faster to compute than floating point. So when you change the numerator and denominator in this delta x over delta t, you change it and try to keep c constant, because that keeps everything kind of constant the way it was. You don't want to create any big big problem in your virtual reality. So you'd like to keep that ratio the same, but it's not necessarily possible to keep it exactly the same. So right around the 1920s, the speed of light dropped, he said. Well, that was a time when we were just starting quantum mechanics. We were just starting to measure, had the tools to measure very small things. After that, we got electron microscopes. We got all kinds of things. Our science kind of blossomed then, and we started looking to things in much more detail. Well, when you look in things in much more detail, you need to have a little more resolution, so when you look, you'll find something, right? So that would have been a really good time to expect the speed of light to maybe change a little bit. And then a little afterwards, it changed again. And well, once you start tweaking the system, usually your first tweak isn't the only thing you have to do. You tweak the system, and then you may look at it and say, well, we could have done that better. We could have maybe changed it. Maybe we need to change it even a little more and keep that C value even more constant the way it was. So you have another tweak. And so you expect maybe several tweaks. That's the way it is when you tweak a system. You have a great, big, complex system, and you have to make a little tweak to it to change it. Typically, those tweaks come in groups. You tweak it a little, and then you see what that did and where you are and where it's going and what you've done, and then you tweak it a little more. And then after you've tweaked it enough that you're happy with the change, then you let it alone until you need to tweak it again. So that would be at least a hand-waving explanation of why right about that time in our history we saw the speed of light, doing a little change, and that it went up a little or down a little, and we're talking about tenths of a percent of its value is what we're talking about. I think it was something like 0.6% of the value of the speed of light. It was like the biggest difference there. So these are small changes that we're talking about, and now they're not small compared to measurement accuracy. That's why it made a big deal, because we were measuring it to 15 decimal places, yet we were seeing changes up at only 6 or 7 decimal places, you see, which means these changes were real. It wasn't just that our error, it was just, well, that's down in the noise. It wasn't in the noise. These were real changes that were bigger than our measurement accuracy. That's what made the whole thing interesting, right? But so that's about a time one would expect this to change, where the resolution needed to boost up a little bit. So okay, now the idea about something in the beginning has more flexibility, more degrees of freedom, and then it kind of narrows down. Well, Rupert kind of has that idea right, but I think he doesn't really see the bigger picture of why that is that way. Basically, what quantum mechanics tells us is that things are probability before the measurement. Once you measure, once you bring data, and it's not just the measurement, but once you bring data into this physical reality, then you have to keep the world consistent. So once you do the measurement of an electron's position, well, now the electron acts like a particle because you have measured it. There's the electron. You see, that's why in the double slit experiment, you do the measurement at the slits, you find a particle, and then it acts just like a particle, and you just get one spot of light. You no longer get diffraction patterns. Now you get a particle pattern, if you will, not a wave pattern. That's because you've measured it. Once you've measured it, you bring it into this reality, it stays here. It's the same with that crystal. Before that crystal was ever done, before it was ever seen before, there were maybe, there was maybe, 10 different ways that crystal could form. And these are all in probability. See, it just doesn't work for electrons. Quantum mechanics doesn't just work for little things. We like to try to believe that, but the basic concepts work for everything. And everything is probability before it's measured and brought into this reality. Once it's brought into this reality, then the data's here. You have to stay consistent from that time. Now, there may be some properties of it that we still haven't measured or seen yet, and those properties still remain in probability, you see. So that crystal he was talking about, first time anybody had created that crystal, there may have been 10 or 20 different ways that crystal could form or could be. And a random draw is taken from that probability distribution, and a result is what is measured. From then on, that's the way those crystals act. You see, let's look at it in astronomy. Somebody looks through a telescope that's a better telescope than anybody's ever looked through before. And they look into a part of space that's never been seen before at that resolution. Okay, there may be 1,000 different things that could be in that piece of space, in that volume. And they all have a different kind of probability that they might be there. At the time the measurement's made and the person looks through the telescope and takes the picture, a random draw is taken out of that probability distribution, and that's what they see. You see, one of those 1,000 things that are possible are picked. And now they're not just all have equal probability. You know, there's some of them have much higher probability of being picked than others. So that's what I mean by a probability distribution. And you take that random draw, and that's what you get. Now, from then on, anybody else looks with that resolution at that part of space, they'll see the same thing. You can't have things coming and going. See, that makes this a very squirrely virtual reality. So that's how that works. So what he's talking about is really a fundamental nature of a virtual reality like ours. This reality of ours is not deterministic. You know, people talk about simulations. Okay, it's a virtual reality. That means it's a big simulation. They think about a deterministic simulation that has to specify every particle all the time. You know, that's the big clockwork thing, right? It's a big machine. You just have to know where all the particles are and what they're doing. Well, it doesn't work like that. It's based on probability. With the virtual reality has a rule set. Okay, that's any virtual reality needs a rule set that defines, you know, energy interactions, things like that. So it defines properties of things. So this rule set often will have lots of different solutions to a particular problem. In other words, something could be like this crystal or like what's in outer space. It, you know, within the rule set, there may be 1,000 things that could be in that quadrant of space, all within the rule set, some more probable than others, you see. Now, things that don't abide by the rule set, you know, like you look out there in that quadrant of space and see a bunch of little pink elephants flying around, flapping their ears, you see, that doesn't agree with the rule set, so that's not going to be there. But the things that do agree with the rule set, what's that? Well, it's basically our science, right? Our physics, our understanding of how the world works. So those things that don't agree with the rule set, then, you know, they're not in there. But there may be 1,000 different things that all agree with the rule set. The one you get is the one that you take with a random draw from all the probabilities. Now, that, again, I say the random draw isn't that there's an equal chance that any one of the 1,000 could be there. I'm not saying that. The probability distribution is what you're taking a draw from. So some of them are more probable than others. Okay. So anyway, that's kind of the big theory. We don't have time to go in and explain all that. But once you understand that, then you see that what Rupert Sheldrake was talking about how you have, you know, you develop kind of a consistency. You develop a sense, a narrowing of the way things are. Okay, the degrees of freedom start to constrict to where now things need to be this way because of what's happened in the past. And that's true. Okay, so if they measured everything around that piece of space but just hadn't looked at that piece of space yet, then there may not be 1,000 things that could be in that piece of space. If they had measured all around it but not looked at it, you see, now there may only be 3 things that are within the rule set, that are probable for that chunk of space, because it's been narrowed because of everything else that's there, you see. So there's fewer choices. So now you take a random draw and you pull out one of those three things. So yes, history and the way things are and the things that we've done and the way that we've been and the stuff that we know and the experiences that we have do modify what the probabilities are, okay, of what of what we bring into this reality. So that's the way it works. Now, maybe I'm taking too much, going too slowly here, but Rupert has this idea of a morphic field, and actually, I'll say it's a good guess. You see, because physics created this concept of fields really not that long ago. It's kind of a new concept in physics, 150, 200 years it's been around. And when it first came into being, a lot of physicists didn't like it. They called it action at a distance. And they said, it just doesn't feel right, this action at a distance. Things happen, and we don't really know why, but they happen out there, but nothing material seems to take place, but it just happens. Action at a distance was a real tough pill for a lot of physicists to follow. Well, the reason why that was such a tough pill is that there really are no such things as fields. See, fields don't really exist. Now, I know all your listeners are saying, what? Fields don't exist? How do cell phones work? They work with fields, right? Well, you have to understand the way virtual reality works. If you were simulating a cell phone and a computer, would you produce an electromagnetic field inside the simulation? No. You would calculate the field values inside the simulation, but that's not, calculating field values is not the same as having a field. You see, it's the same with particles. Like take the electron again. We look at the electron, and electrons are very common, right? I mean, that's what makes the light bulbs work. All this electronic gadgets we have here that we're looking at each other on Skype, we're recording on stuff. All this has to do with our harnessing the old electron. So how can you say that electrons don't exist? Because they really don't exist either, you see. The way these come into being is that, and it's the same way fields come into being, is that we measure effects. Okay, we measure effects. So we look at something very small. You know, we want to measure the electron's mass or its charge or something like that. We don't actually go in and grab hold of an electron. It's too small. We measure its effect. Okay. So we measure the effect of an electron on an oil drop in an experiment that makes the oil drop go up or down based on charges we put on plates and so on. This is how we're going to calculate its charge. And we say that, okay, the electron acts as if it has this mass, as if it has this charge. You see, that's different. The electron is our model that we make up to describe the effects we measure, you see. And then, because it's our model to describe the effects we measure, then we begin to believe in our model, that the thing's really there, that electrons really do exist. You see, so we had back in the good old days of science, which was when I was in school, when I was in high school, you know, I was told an atom had this nucleus, and that was like a basketball, and then they had these electrons, which were like little BBs zinging around it in orbits, right? Because that's a good materialistic philosophy model, right? There's these chunks of mass and little charges zinging around it. And then later we find out, well, it's really not like that. As we get to dig deeper, there's not any really little electrons buzzing around anywhere. It's just a probability cloud. You see, of the probability that an electron might be someplace, there's this cloud, and the cloud actually goes from plus to minus to infinity, but it kind of groups up around the nucleus, and these electrons, you see, are not really physical things, they're potential things. But they act as if they had mass and a charge, you see? Okay, that's the difference. The electron's a model. It's the same way with fields. Electromagnetic fields. Okay, we take a little device that measures say the electric field strength, and we stick it up in space somewhere, and it gets a reading. Okay? Now we model that as saying there's a field. That's why it gets the reading. It gets a reading as if there were a field there, you see? And then we find out that the field drops off as 1 over r squared, r being the distance we are away from the source. So we have a model now of a 1 over r squared field, you see? But the field itself is just what we, as if there were a field, as if there were an electron, as if the electron were a little mass with a charge. So our measurements, we're not measuring the thing in itself. You see, that's the thing. See, science doesn't do that. What science does is it measures something that infers, that as if, that's the inference, as if it infers the electron. It doesn't actually measure the electron. We infer the field because of how we can measure the, electric potential with an electric potential measuring device as we get farther away from a charge, you see. So we know that there's this electric field emanating from a charge. Well, the field is our model. We begin to believe that fields are physical things. And that's why the physicists, back when fields were first talked about, didn't like it. Action at a distance. Didn't feel right. You see, didn't meet their idea of the Newtonian world that was a machine. They if something wasn't there to move something, they didn't want it to move. This idea that a field moved it, they didn't like. So
that's very interesting.
Yeah. So as it turns out, they were right. There really is no field. You see, there is no electron. These are just probabilities. So the world works according to a rule set, and the rule set affects our probabilities because things have to work within constraints of the rules, right? But sometimes there's multiple answers within those constraints, and then you have probability. And when you have probability, then you draw of those things that are probable, you take random draws from probability distributions. So that's the very nature of a world. So when Rupert had this problem, he saw things that were true. He saw the dogs knowing when the master came home. He saw other kinds of things that told him there was some kind of communication, some kind of inference going on here that the dog didn't know, and that somebody does know when they're being watched, so that he sees these things. And just like the physicist, he's a good scientist, he wants a material answer. He wants something material to say this is the cause. Well, what did the physicists all do? They made up fields. They said, oh, it's a field. It's an electromagnetic field. And yes, an electromagnetic field has no weight, doesn't take up any space, doesn't have any of the properties that we, give a real thing, but it does have the property that you can measure field strength various places, you see. So that's the thing. So fields really don't exist either. In a virtual reality, you don't need an electric field. All you need to do is be able to compute what the electrical potential is at any place in space. That's a calculation. It's not a field, you see. Now I know people their eyeballs are rolling around in their head and they're trying to grasp at what I'm saying. If you go back and try the Calgary workshop on YouTube, that'll give you some of the basics. Or if you get the books and read them, that'll give you some of the basics that this makes sense. Right now, I know it sounds a little far out and a little crazy because we're used to thinking of things in a certain way. But in a virtual reality, you have to remember, this is a computed reality. Our physical reality is just information. And science is being pushed into that corner, kicking and screaming. They don't want to go there, but the results of their experiments are dragging them there, whether they want to go or not. And they're saying, yes, that this reality is virtual and it's just information. That does solve a lot of our problems in physics if we just take that concept, but, they'll turn right around and say, yeah, but that doesn't mean it isn't a big machine, because that's really what they want to believe. So anyway, physics is getting to that point where they see it as a virtual reality, but virtual realities don't have fields. They have virtual fields. the virtual fields are just calculations. So we calculate electric fields at various points in space, given the sources that are around that would create that electric field. And we can calculate how one electric field might interfere or interact with another. And we can do all that, but these are just numbers. It's just information. You see, at a particular point in space has a certain information. It goes at that point, depending on things. It's not that the computer has E&M fields running around through the transistors, you see, delivering energy here and there. It doesn't work that way. It's information. So anyway, Rupert came up with a field. Why not? That's what all the rest of the scientists did when they saw something happening somewhere else and there didn't seem to be a connection, and they posit a field. So, all right, let's say there's a field. So he called his the morphic field. There really isn't a morphic field. There really isn't an electromagnetic field. Fields really don't exist. They're just a model. It's the way we describe things, and we very much like physical causality. So when we get that field, when we get that reading of that electric field, or when Rupert sees that the dog knows, that the master's on the way home, then we want to model that like there's really something doing that. We want a causality that we can talk about and write down and write an equation. So then we say, well, it's a field. And here's the properties of the field. And of course, that's the properties of the rule set that lets you calculate the information that describes the result that you measure. So anyway, so there is no morphic field in that sense. But if you let morphic field be a metaphor, like an electric field's a metaphor, for the causality in a virtual reality, well then fine. Then all these fields can be metaphors. They don't actually exist then. From dogs and their masters to double slit experiment to galaxies, what happens is all consciousness is netted, you see? So we all are connected. Now, the dogs are more connected than we are. We could be connected, and some of us are very connected, but most of us aren't. Why? Because we have this big left brain thing going on in our heads that doesn't pay any attention to our intuition. And if our intuition says, wait a minute, listen to me, I'm your intuition, we tell it to sit down and be quiet. We don't trust it. Where did that come from? Nonsense, you see. So the dogs don't do that. They don't have this big left brain thing going on that kind of gets in the way of them being in touch with their intuition. So a lot of other critters, and some very right brain people, are very much in touch with their intuition. They know all kinds of things. They probably know, when their dog's coming home. They probably know other things, you see, if you're very right brain and you don't get in the way of it. It's there. Why? Because all consciousness is netted. There's another reason. If you look at my theory, you'll see that there are databases. There's the probable future database, and then there's the past database, both actualized and unactualized. All of this information is available. In fact, that's where your intuition gets a lot of its information from, is from these databases. So everybody has this information available to them all the time. And this information gets grouped up by the system, by the larger conscious system, by groups. If you consider yourself to be a member of a group, then there's kind of a group sense. You take all the information, all the data that's in these databases by all the members of the group, and you can distill out an essence of the group. And you, as a member of this group, start to take on some of the properties of this essence because you're a part of that group. You get associated with that. In other words, you're intuitively connect to that information. So that's just the tip of an iceberg. I'm taking way too long here to go through these, so we'll just let that go. But there's a lot more to be said. Okay, we could derive Jungian archetypes here. Where do the Jungian archetypes come from?
Okay.
We can derive much of what Rupert sees, and that's the key thing. What Rupert sees and what his experiments have told him are right. He does see these things happening. That a morphic field is somehow responsible for them, well, a metaphor, but not exactly right. A virtual reality based upon consciousness explains all of it in detail, without fail. All of these things are explainable.
Okay. Thank you, Tom. That's very, very interesting. Let's move on to the fourth dogma. The total amount of matter and energy is always the same. And what he's referring to here, it simply sprang from nothing, like the Big Bang.
Right, the Big Bang. Well, he's right. That is a dogma, and actually, the Big Bang is not a bad theory. It does explain an awful lot of things about the universe, so it's not really a bad guess. But the problem is, if you have this materialistic philosophy, and your universe is the creator of everything, in other words, everything is material, so everything in this universe is created by things in this universe, well, then where does the universe come from? Well, it comes from the Big Bang. Well, where did that bunch of energy at high pressure and whatever, that was before the Big Bang banged, right? Before the run button was hit, before the Big Bang actually banged and expanded and our universe came into being, it couldn't have come, that little ball of stuff couldn't have come from our universe. Well, originally they thought maybe they could swing that, and they also talked about the Big Crunch. So the universe expanded, and then gravity pulled it all back together, and it all crunched in a Big Bang, and then it expanded, and this thing just was cycling like that. But then that turned out not to be the case. It doesn't. Things aren't slowing down as it goes out. The size of the universe is accelerating. It's expanding. It's not slowing down. So the Big Crunch really wasn't so. So we're left with this Big Bang that started from nothing, out of nowhere. And that's kind of a big problem, right? Because if you're a materialist and everything has to come from, the material in the universe, this universe is all there is, there's nothing outside of this universe, then how did this come about? Where did the Big Bang come from? Well, again, scientists don't want to go there because obviously, they can't answer that question. Oh, well, we'll never know, so let's just forget about it because nobody will ever know. So that's what you say when you run into a wall that says, you're full of crap. You have holes in your theory. Your beliefs aren't right. You just throw up your hands and say, oh, well, nobody will ever know the answer, so let's go on with something else. It's kind of the reaction that you have. So, in my thought, this Big Bang is the big digital bang. That's when the run button was pressed on this virtual reality. Now, the virtual reality wasn't programmed, it evolved. So you have initial conditions, which were a lot of energy, high temperature, high pressure, small space, etc., like Big Bang, right? That's the initial conditions. And you had a rule set of how things could interact. And then you push the button and it starts to interact. It's a dynamic simulation with a rule set and initial conditions. And it evolves. And what did it evolve to? It evolved into our universe. It's still evolving. It's all on a computer. It's just a simulation. So where did it come from? Okay. Fredkin says other, right? Well, where did it come from? Well, it's a virtual reality created within this larger consciousness system. And if you want to go look at my work, you'll see there's a really good reason why it had to be created. It wasn't just created because it just was, and there's no reason for it. There is a reason for it, and why we as consciousness interact with it. There's a good reason for that too. So all of this is rational, and scientific if you get into it. But I don't want to go into all that. That's too much for this. But anyway, he's exactly right. This idea that it sprang from nowhere is silly. Matter of fact, I'd say that's a mystical assumption, that our physics is based on a mystical assumption. Take that, guys. That's just the way it is. So the idea that total amount of energy is always the same, that just comes out of this thing of conservation of energy. But when you have a virtual reality that is probabilistic, almost anything can happen. There's very little that's impossible to happen, although there's lots of constraint based on what already has happened, what has evolved. So using words like always get you in trouble. All right, I'll just let that go. You know, we could say more and more and more, but we'll go on to the next one. I got to pick up
All
the
right.
pace here.
The next dogma, number 5, there is no purpose in nature.
Yeah.
Now, you've already alluded to this.
Yeah, no evolutionary purpose. Well, of course, that's nonsense.
Yeah.
You don't evolve without a purpose, right? If we look at our what we call our physical reality, what were the constraints there on evolution? Well, survival and procreation, right? That's eventually, when you talk about life anyway, the evolution of life forms, it's survival and procreation. You have to have some purpose. There, the purpose of life was to survive and procreate. In an information system, because we're talking about consciousness being an information system, within an information system, the purpose is to lower the entropy of the system, to create information, to create something that matters, that's significant, that's information. Okay, and for things then to return to randomness, where there is no information, that's dissolution, that's de-evolution. And eventually, if everything becomes random, that's death. The system doesn't exist anymore. There's no information. It's just randomness, nothing, you see. So in an information system, the purpose is to evolve to lower states of entropy, more content. And that is the evolutionary purpose in nature. And in this virtual reality, there is an evolutionary purpose for the larger conscious system. There's also an evolutionary purpose of why the system would want to create this virtual reality. There also is an evolutionary purpose for why individuated units of consciousness, pieces of this larger conscious system, would want to play in this virtual reality game, okay? Which is what we as consciousness are. You know, our bodies, our virtual bodies in this virtual reality just are representing avatars. Consciousness is what's actually making the choices there. So I won't get into that too much, other than to say that there is purpose flows down from the idea of you want to minimize entropy. That flows down through everything, and each has a purpose. So indeed there are purposes in nature, and anybody who just looks at nature, it's obvious that there is a purpose. Otherwise, things in nature would be random. You know, they're not random. It has a purpose, and there are large purposes all the way out to consciousness, all the way in to our virtual reality with its rule set. You know, all of them have purposes. Our virtual reality is to help the larger conscious system evolve. We're part of this virtual reality, and our interaction here is part of its strategy to evolve. So we're part of that evolution of the larger system. And that's a much longer story that you'll have to go, back to my work to get elsewhere, but we'll move on. So indeed it does have a purpose.
Number 6 of Rupert's 10 Dogmas of Science is heredity is material.
Yeah, heredity is material.
Carried in DNA.
Yeah, and that's wrong. Heredity is not material. Now, the DNA provides the framework, if you will. It provides the framework and the process, but it's not all there is to it. You see, it's almost like the DNA is the hardware, is the computer, if you will. But there's also an operator and there's software, involved that you can make the computer do all kinds of different things. So the DNA is just the structure, but heredity and the material, the information that's in the genes, that is derived largely from consciousness. It's derived from the rule set. The rule set has certain rules about the way things interact, and that's part of it. But consciousness is also a big part of heredity. Now we think about things like, well, certain traits. Of course, Mendel did his experiments, and he knows that there's certain traits, and you mix different kinds of plants together, you get different kinds of things, and you mix, this color of geraniums with a different color of geraniums, and you get so many percent will be color 1, so many percent will be color 2, and so many percent will be a mixed color between the two, or variegated color. And basically that's the rule set, talking about how these things work. But within that rule set, the information in it and what information's there and how that information gets expressed has a lot to do with consciousness. You see, it's not just a big machine, a big mechanical, biological machine. Consciousness affects that. And you don't have to have something going on for many generations to create something in your genetic material that you get to pass on. You think about, here you are in this one life packet, this one experience packet, and the things that you experience, the things that you think and feel and do and experience can be passed on to your offspring. You see, you can affect your own genetic material in such a way that those that come after you now are a little different in their genetic makeup than they would have been if it wasn't for you. You see? Now, our science would disagree with that. They say, oh no, it takes, you don't change things in the, in the DNA unless there's, hundreds of years or thousands of years worth of evolutionary pressure to make certain things change. And that's true also. You do have that effect. But also, just in the individual effect, your life will produce a unique genetic contribution to your offspring. Now, you can't change it but so much and in so many ways. You're limited. You're not going to produce a baby with 4 heads or something because you've stared at pictures of babies with 4 heads. It doesn't work like that. It's not that simple-minded. But things that are important at a fundamental level, not at an intellectual level, but at a fundamental level, will work their way into slight variations in your DNA. So you're adding to, subtracting from, and putting your own twist on the DNA that passes through you. It's not just a big machine that functions whether no matter what you see, hear, do, think, or feel, it just chugs on along without you. You're irrelevant to it. You're not. So we modify our DNA. We modify it, and we modify it just from our experience here, things we think and feel.
Very interesting. Number 7 dogma, memories are stored inside your brain.
Yes, well, I definitely would have to agree with him that that's a dogma, because there is no brain, actually. It's a virtual brain. There's we have this virtual reality that is a simulation of a virtual world, and in that virtual world there are virtual beings with virtual bodies and virtual brains. And all of that is just information. Your brain does not store or process anything. Okay, now people will go, oh, wait a minute. Sure it does. You cut out a part of your brain and now you can't do things because you cut out that part that held the memory. No, it's just a virtual brain and a virtual body. The way it works is that the simulated reality, the virtual reality we live in, has a rule set, and it evolved. Now, the rule set and how it evolved creates constraints, and it creates constraints on a data stream that goes to you as a consciousness. So think of yourself as you're an individuated unit of consciousness. That's it. You're non-physical, an individuated unit of consciousness. You're not a body. And this virtual reality creates the constraints on the data stream that's fed to you. Okay, now all virtual realities work this way. If you're playing The Sims A data stream is sent by the SIMS computer, right? The SIMS mainframe or the SIMS server, whatever, sends you a data stream. And that data stream gets displayed on your monitor. And you look at a bunch of pixels that light up and unlight and you know, have different colors. And you take all of those all that pixel data, and you interpret that as the Sims game. There's houses and cars and grass on the lawn and children and swimming pools, and all of those things is in your head. You interpret all that from little flashes of light on a flat screen. You see? You create that image from the data stream. Well, here we are. It's the same thing, except we're not on a two-dimensional data on a flat screen. We get three-dimensional. So this, in our simulation, wasn't programmed like the Sims. It evolved, but it works the same way. The simulation and its rule set create the data stream. They create the constraints on the data stream that you get, and in your, as consciousness, you get the data, and from that data, you project this virtual reality. Okay, the virtual body with its virtual brain is an avatar for you, just like your elf is an avatar for you in the World of Warcraft virtual reality game. Okay, it's another one that is well known. So it works the same way. You are the consciousness. You are the one. You, the consciousness, the individuated units of consciousness, are the ones making all the choices. You make the decisions. You have the feelings. Just like your elf. You tell it to run or fight or jump or dance, and it does it because your intent, and of course also your click on the mouse or whatever that you have to do to translate your intent back to the server, right? Your intent causes that elf to do whatever that elf does. If you don't have any intent, which means you don't give it any information for it to do anything, it just sits there. It doesn't interact. Well, that's the way this is, you see. It's your intention. You interacting, you send data back up the data stream to the server that's serving the physical universe virtual reality. And you create those interactions. So the brain doesn't store or do anything. It's just a virtual brain. Now, how come then when some other virtual character hits your virtual avatar in the head, and that virtual avatar now has to walk with a limp or can't remember, what its name is or what it can do? Well, how does that work? Well, the rule set says that if something with enough force hits a skull and caves it in with enough force at a particular place, the rule set will tell you that that creates a constraint. So now you've just changed the constraints. Before you didn't have that constraint. You get hit with a pipe, now you have a constraint where you didn't have it before. That constraint limits the data in your data stream. Now you can't talk, or you talk with a slur, or you walk with a limp, or you show you can't remember, you don't have access to the data you used to have access to, because the rule set has calculated, what the consequences are of being hit in the head with that pipe. So that's the way it works. There is a rule set. It's the same with your elf. If your elf jumps off a cliff in World of Warcraft and the cliff is high, your elf will be hurt. It'll lose. It'll get damaged. It'll lose hit points. It'll lose, however damage is configured there. It might die. If the cliff is high enough, your elf will die. So why is that? Well, the game, according to the rule set, computes what the new constraints are, put on your character, and then that's what you get. So now your elf is sprawled out on the ground at the bottom of the cliff. Well, you're sprawled out in the park where you got hit in the head with by the mugger. And that's just the way the rule set is. So it's just a virtual brain. It's not a real brain. It doesn't do a thing. So the idea is memories are stored inside your brain. No, nothing's stored inside your brain. Nothing at all. It's a virtual brain. All the memories are stored inside the consciousness. Consciousness is non-physical. It's not a physical thing. Consciousness, you as a piece of consciousness are like that the larger consciousness system that created this Big Bang, right? When the run button was pushed, It doesn't belong in this physical reality. It's not part of the virtual reality. Consciousness exists outside of this physical virtual reality. I say physical with quotes around it because people claim that it's physical. Well, you know, the elf in World of Warcraft thinks his map that he walks around in is physical too. To the elf walks into a tree, and what happens? He bounces off. If he runs into the tree too fast, he gets hurt, you see. So as far as that elf's concerned, his reality is physical. It hurts him when he falls off cliffs. He drowns if he stays underwater too long, etc. He has to open a door before he can walk into the building. You see, it's a physical reality to that elf. That's his physical reality. Well, that's the same way. Our avatar, our body, sees this reality as physical. So here we are, we're consciousness, and from our viewpoint, from our data stream, you see, it's a physical reality. Just like when you're playing that elf, you have to open the door, you have to walk around trees and those kinds of things when you're the player, because that virtual reality you're playing in is, quote, physical, unquote. Otherwise, you could walk through trees if it wasn't, and you could fly off of cliffs. But the rule set doesn't allow that. Well, neither does ours. The World of Warcraft and the Sims rule set was patterned after ours, you see. But now again, that was programmed and ours is evolved. There's a difference there. So absolutely, memories are not stored inside your brain.
All right then, thank you. On to number 8, mind is inside your head.
That's definitely another delusion or another dogma. It's very much the same sort of thing. Now, of course, Rupert, he says our minds are extended, and he means by a physical morphic field, because we materialists just really like physical fields, even though they don't weigh anything. We can't hold them, we can't put them in a box, that kind of thing. But anyway, a physical morphic field, it's beyond our brain in the act of perception. He says that in his field. Well, you are the mind. You are the individuated unit of consciousness, a piece of this larger consciousness system playing in a virtual reality game. So mind is not inside your head any more than memories are inside your head. All of your awareness, all of your consciousness is not in this physical reality. The physical reality is just a virtual reality. It's like the World of Warcraft. And you, the player with the mouse and the keyboard, you're the mind. You're the memory. And they're not inside your elf's head. Now, it appears that way because your elf sees things and, scary, and he runs away. So it appears that your elf is frightened of something. But you, with the mouse and the keyboard, you're the one that told that elf to run away, you see. And you remember where that elf's been. And you remember that the last 3 times you tried to go through that cave, something jumped out at you from the left side. But it looks like the elf remembered that. If you're down there with that elf, the elf comes up and he kind of peeks around that corner now because that elf has learned, you see. So we'd say, gee, that elf has memory, and there's memory in his brain. And he's smart because he's being careful. You see, well, it's not that the elf has brain and a mind and they're inside his head. It just looks that way. Basically, it's a virtual reality, and the mind and the memory is inside the head of the player who has the mouse and the keyboard. And we, as individuated units of consciousness, are the player in this virtual reality game. And there is a reason and there is a purpose of why we're here and what's going on. All right? Let's go on. I'm going to make this thing draw out forever if we don't keep going.
Well, this is good. Number 9, dogma, psi phenomenon is impossible and illusory.
Yeah, well,
we know that's not.
Yeah,
true.
we know that's not true, because basically what happens is we call all the psi phenomena, psychic phenomena, that's the what's that stuff called? What's the one word that groups all that up together, Donna?
Oh. Paranormal?
Paranormal, that's the word I'm looking for.
Okay.
I don't know why I'm having such a hard time with words today, but okay, psychic phenomena all fall under what we call paranormal. Okay, and paranormal means beyond normal, not normal. We can't explain them with our normal materialistic belief. Well, that's quite true. You can't explain these things with a materialistic belief. But if you understand how reality actually works, if you see it as as consciousness is the fundamental thing, and that this reality is virtual and so on, then the paranormal just becomes normal. There is a perfectly rational scientific explanation for how all of these psychic or paranormal things happen. They're not paranormal, they're normal. It's just that our science is very limited in what it understands. It's limited in its viewpoint. And it's fighting tooth and nail to stay limited, right? To not go beyond and not see bigger pictures, like we said earlier. It's frightened to go down that path. But if you do go down that path and you have a bigger picture of how the world works, then the paranormal just becomes normal. And people who can tell that somebody's staring at them from behind them, how do they tell? All consciousness is netted. And you have database that your intuition can connect to that gives you all that information. So anyhow, that's once you understand how it works, then all these things are not paranormal at all. They're not only not impossible and not illusory, but they're very fundamental. It's just, they're just part of how the world works, just like gravity or force and acceleration or anything else. They have rules, and they are repeatable. It's just that when you deal with things that there's a lot of uncertainty in process, then you get uncertainty in the result, and that's why they are a little difficult. But that's true of anything. Any process that has a lot of uncertainty in it has uncertainty in the result. So they certainly. Psychic phenomena, we'd have to call the placebo effect as a psychic phenomena, because it says that in this mechanistic biology where we're just machines, you talk to the machine and say, you take this pill and you're going to get all right, but there's nothing in the pill but sugar or sawdust, and the person gets better, compared to a control group that you didn't tell them to do anything. You just gave them a pill. Well, why is that? Somehow the consciousness, when you change its viewpoint of its health, it changes what the body does. Oh, that's paranormal. That shouldn't happen in a machine. You can't talk to machines and have them do things differently. So just the placebo effect that is part of our legal requirement to get drugs out for sale. Nobody doubts that there's such thing as a placebo effect, but that's a paranormal event that's going on there. Anyway, that's kind of silly, but that's people who want very desperately to have a materialistic view, who want there to be nothing else to reality than this universe and the material world. They run into these events, remote viewers, are well documented, and because they can't explain it, it's just like the double slit experiment. They do one of two things. If they are a part of it and they actually can't deny it because, somebody remote viewed in their house and described everything that's in there that had never been there, or they remote view and it happens to them and they can't deny it, then they throw up their hands and says, oh, well, nobody will ever understand it. Dismissed. Or they just flat out say, impossible. Can't happen. It's not like that. Particles aren't probability distributions. That's just what that's just what the math says, but that just interpretation doesn't make any sense, and we'll just never understand, you see. So you either deny it or you claim that it's a mystery that's unsolvable, one of the two. So,
well, Tom, we've both seen a lot of evidence of very talented psychic mediums and people who can recall past lives. Dr. Brian Weiss, a well-known psychiatrist, has well-documented experiments that prove that people can recall past lives, and that's certainly not anything to do with the material world. We also know very talented psychic mediums such as Marla Freese, who communicates with those who've been deceased. And people, this is quite well accepted. Over 50% of the population really has some kind of psychic experience, if not more than 50% of it. So I think one of your former statements that the people will be the ones dragging the scientists into the new science will be true, because they've seen enough evidence that this is not simply a materialistic world.
Yeah,
there's just too much evidence.
Right, well, you're quite right. You know, I sometimes get people to say, well, you know, prove it to me. I want to see, you know, some kind of paranormal event, and then I'll believe. You know, well, the point is not to be a believer or not believer. You know, if what you need to do is believe, then you're going at it from the wrong, you know, in the wrong way altogether. It's not about belief. It needs to be part of your experience. If it's not your experience, it's not your truth. There is lots of evidence. I say you don't need to see some kind of, you know, miracle in front of yourself or whatever. Go read, you know, go read Dean Radin's books. You know, he does research. He's been doing research for years. There's enough there to keep you reading for the next 6 months, you know, and you will find very careful experimentation. Read Puthoff and Targ's book, I think it was called Mind Reach, about some of the experiments they did. Go Google remote viewing, and there's some remote viewing groups that are very scientific, very strict protocols. And, you know, look at their work. You know, this idea of that, there's never actually been anything paranormal that's ever been, you know, seen or discovered that's ever been scientific. That's nonsense. That's another belief. Go to Pear Labs, for goodness sakes. You know, Princeton Engineering Anomalies Research. They can show you research that's over 1 billion to 1, their statistical significance. You know, nobody does research at 1 billion to 1 statistical significance. It's 1 billion to 1 that they get the answers they get just by luck, you know. Their research is immaculate. They're very careful because they know people will pick at it because it shows things that are not part of the materialistic philosophy. So they've been very careful. You know, these are all PhD level scientists doing research. Started out as the Princeton Engineering. I don't know if it's still part of Princeton Engineering or not. I don't know. But in any case, the research is immaculate, and they show that people modify things with their minds. Okay, it's a mind over matter, or a mind affecting material things, such as the placebo effects like that too. But they take very specific research where minds modify things like random number generators or other such things that shouldn't be able to be modified by consciousness, by mind, you see. And their research is immaculate, well done, scientific, in laboratories, very, very detailed error analysis, etc., etc. So this idea that prove it to me, gee, go get a book, you know, do a little research. An hour on Google ought to show you, you know, thousands of experiments that are completely scientific, not just, oh yeah, I went to bed last night and, you know, I saw a 3-headed man and then he took me to my past life. You know, okay, that's not scientific, that's anecdotal. But there's lots of good science that is there. That, you know, and again, you were talking about past lives. You know, what about the 6-year-old that gives all the details about this plane that he was in that got shot down and so on? Well, he's 6 years old. Now tell me, you know, he went someplace and looked that up in a library and memorized the pilot's name who was in there. You know, well, that data wasn't available. Well, how did he do that? Oh, well, 2 choices. We either deny it. It didn't happen. All those people that said he said that just all lied. You know, it's like they bring the dinosaur bones in and bury them in the ground, you know, in order to discredit us. You know, it's that sort of stuff. It's all a lie. Or, well, okay, it's just one of those mysteries we'll never understand. Let's go on. You see, those are the 2 choices. Well, Science does them both. They take this paranormal research and they deny it. Pear Labs, with all of their scientific muster, which is very good, high-tech analysis in laboratories with, very qualified scientists and so on. Guess what? They can't get their work published in mainstream physics journals. Why? Because it doesn't uphold the dogma, doesn't uphold the scientific belief. So even though the research is immaculate, and even though it's perfectly clear, they won't publish them because they don't have the right answer, according to the the trolls that guard the bridge of what it is we should believe. So in any case, that's just this idea of, well, if it were really scientific and if some scientists actually did it, boy, that would change things. That doesn't change anything. Demonstrations are irrelevant. You don't need demonstrations. It's been demonstrated thousands of times over centuries. Come on, you go all the way back to J.B. Rhine down at Duke University. And, it's not like this is brand new, folks, and we've only, done this. The Pear Labs has been probably going on for 20 or 30 years. It's not, there have been the stuff that Puthoff and Tard published. It's been out there for 25 years. This research has gone on for centuries, and it's well documented, and much of it has been very carefully done under scientific conditions. And one of two reactions: well, that's amazing, but we'll never know anything about it, so let's just forget about it and go on. Or, oh, they're all liars. They're just saying that that's the way it is. They're just a bunch of fools who are easily confused, and they just, if I were there, I'd be able to tell what was wrong with it, that sort of thing. And those are the reactions. That's called denial. And that's all we get. And we're still in that denial. Well, that's the same thing they were fighting back when Copernicus and Galileo were trying to get some rational thought. What did they get? Denial. That couldn't possibly be the way it is. You see, because you couldn't possibly find dinosaur bones there because they couldn't possibly be that old, because so you get all of this denial. And unfortunately, the scientists don't see that they are now the high priests that tell us what to believe. And they are fighting to maintain that status, just as the old religious high priests did many centuries ago. And they're using the same techniques. They want to ban heretics. They want to keep that message from spreading. They deny, and they just either, they just won't look at the facts. There's a Pear Labs, all this good research, just refuse to look at it. And they say, well, the things they get are very small. Well, yeah, okay, so atoms are small, molecules are small. That doesn't make them unimportant. They're small for a reason. If you understand the way that works, how it is that mind changes matter, they have to be small because of the experiments they're doing. You can only modify probable future inside of the natural uncertainty of the system. And they're using very precise systems, so they will only get small variations. They can't get any more small variations. It's just, so there's a reason why it has to be what they do, but their variations are hugely significant because, let's say if you have a random number generator and you generate a very small bias to the positive side of the mean. Instead of getting the mean after 10,000 random number draws, you get something a little positive of the mean. Okay, well, that's not too amazing. But let's say that you do that 10 times in a row. Every time, all 10 times, you get a random number that's positive of the mean. Well, now that's getting a bit odd. Half of those times you should have gotten something that was a little negative of the mean, shouldn't you? And if you did it 1,000 times, there ought to be about 500 of them that were a little slightly negative of the mean and 500 of them that were slightly positive. But if you do it 1,000 times and all 1,000 are always positive, and you go look at your machine and say without intent, they all hit the mean. You know, plus or minus this tiny little bit. You get your intent, and suddenly your intent to make it say go positive, then it goes positive. Your intent to make it go negative, it goes negative. So you can control this a bias. You can actually put a bias in the system with your intent. These are the kind of things, some of the things that they do at Pear Labs. Well, that bias is small, but it's consistent. So if you consistently use your intent to bias it to the positive side, and you do that 1,000 times out of 1,000 tries, that's like flipping a coin 1,000 times and getting heads every time. You see, you've said something very dramatic. You've done something very dramatic, even though the numbers are small. That's kind of what's going on. But people look at that and they say, oh, well, you only moved it by, 1%. Well, the variation statistically would have been 1/4%, and you moved it a whole percent. And they say, yeah, but that's just small. That just happened that way. Well, that's, again, it's denial. The Pear Labs stuff is really good, and they can show you the statistical assessment of their statistical, what they call statistical significance of their answers. So, psychic phenomena is impossible and illusory. That's a statement of those in denial, and it's always been the same.
Thanks, Tom. The last one is very interesting. Mechanistic medicine is the only one that really works.
Well, then why does mechanistic medicine have to beat the placebo effect in order to be, commercial medicine? If that's the only one that works, then there is no such thing as a placebo effect, because that's not part of the mechanism. Right? Now they're saying, oh, well, yeah, mind is part of the mechanism. Well, that's kind of admitting failure there in that viewpoint. Mechanistic medicine, they're talking just about physical, not mental. They're talking just about physical stuff. Well, if mechanistic medicine is all physical, if it's just a big biological machine, then what's with the placebo effect? How is it that you can tell somebody something and it changes their health? There's a mind affecting matter here going on, and it's the only one that works? Well, then all this testing against the placebo effect is a lot of nonsense, isn't it? I mean, it's a law. That's silly. Again, we're talking about just denial. Mechanistic medicine is the only one that works. Again, there's thousands of very scientifically done experiments that show that intent matters as far as medicine, as far as healing goes. I mean, research has shown that doctors with good bedside manner have healthier patients than doctors with very brusque, bedside manner. Why? Because intent matters. If the patient feels better, intends, thinks they'll get better, has faith and trusts and likes the doctor, all of that helps him heal. Why do you think they now in hospital like delivery rooms, they find out if they decorate it nicely so it looks kind of homey and it doesn't look like sterile, what it used to be sterile stainless steel, environments. It's almost like you were in a warehouse, to deliver your baby. And they find out if you have a much more comfortable environment, there's fewer problems. Why is that? Why are they doing that? Just because it feels good and it makes everybody happy but doesn't have any effect? No, the reason they did that, it costs them more money, is because they get less problems that way. Everybody knows that people can heal themselves and can have other people heal them with intent. I mean, that's something that's probably been going on for as long as written history. That's not like that's a new thing either. And again, there's a lot of good research that shows that that's the case. And to deny it is just, the high priests are not willing to let go of a process that has put them in power and that serves up a world that they feel is the best world. Again, it's not just that the scientists, as the high priest, are greedy and they just want to keep their power. It's not that. They really fear that if they let go of their materialistic basis for reality, that the world will fall apart. It'll go to hell in a handbasket, because now, instead of having measured answers for everything, there's going to be a lot of uncertainty. And in that uncertainty, people will take advantage, and you'll get back to this belief-based nonsense that is how we were before there was science. And that's why they are frightened about it. It's not just that they're greedy for power. They see it as a really, really big problem. But the thing is, they have to realize that it's still science. They just need a bigger picture science. You see, the My Big Toe science is science. It's as much science as evolution is science. It's science, and it makes predictions. It's falsifiable. It explains the results of experiments. You see, it's science, but it's a science that tells you that you can modify heredity, that there is nothing in your virtual brain, that's it's just a virtual brain in a virtual body. Your mind is not inside your head. That psychic phenomena is just like any other phenomena. It's just phenomena of consciousness that is outside of the materialistic viewpoint. And if you have a bigger viewpoint, it's not a problem. It'll tell you that you can heal with intent, that you can modify future probability with intent. And again, there's constraints on that. There's within limits. It has to do with uncertainty and other things. It's not like, oh, you can use your mind just to do anything. All right, I want to, I'd like a new house, so I'll just use my intent to build one over here next to mine. Well, it doesn't work like that. You see, now you're being silly. There are rules. Just like because you can throw a ball doesn't mean you can pick up your car and throw it. You can't get silly about it. There are rules and constraints that the rule set places on us. There's a thing I call the psi uncertainty principle that has to do with psi events and this physical reality. So, in any case, I think Rupert is a great guy. I think he has courage to stand up and tell it the way it is. He is in the category that I would call real scientists. Real scientists aren't afraid to go wherever their research leads them. If the truth is, experimentally found, then you have to have the courage, if you're a real scientist, to stand up and say, this is what I found. Now, Rupert also went on to try to make up a mechanism for how that would work. So he came up with a morphic field. Well, it's not really a morphic field any more than there's an electric field, but it was a good guess in a world that believes in action at a distance and fields, and this obviously is kind of action at a distance. So if you're trying to be scientific, well, make a field, call it a field and let it be a field effect. But there really are no field effects in a virtual reality. It's information, and the information is calculated, and there's another much easier and simpler way to define it all that doesn't require fields. So I think Rupert is a very good scientist because he's had the courage to explore things that aren't understood. That's what science should do. Explore things that aren't well understood, and two, report them. Here's the way this works. And the fact that it's new and different ought to be something that would make it very attractive. You see, good scientists would say, wow, look, we got something new here. Let's get on that. We need 100 people all doing these experiments and seeing if they can corroborate them or seeing if there's any difference. Let's put some time and money into working these things, and maybe we'll learn something new instead of new. Oh, this is not materialistic, and then hold up their crosses and, try to make it go away, you see. It's not good science to have this attitude of and that's what that's exactly what Rupert said. Here's a quote of Rupert's. He said, "Thinking less dogmatically could open scientific inquiry." That's a third grader ought to be able to get that. That's what science should be about. So Rupert's done very well. People like Rupert and Bruce Limpton, they have the courage to say, look, here's what I've seen. this makes, and here's my theory of how it makes sense, and present that. And science should welcome that with open arms and say, hey, new ideas, new things, let's go experiment. Let's see if this guy really, is doing this right. But no, they look at it and say, oh, that violates my belief. Go away. I won't, we won't do that. Anybody who does that is a fool, and we won't allow them on TED Talks. You see, that is terrible science. That's not science at all, matter of fact. That's belief. And
Dr. Bernard Hayes also did some theories with the God theory
right.
in that direction as well.
Exactly, another physicist, and put off and Targ go in there too. They're both physicists. You see, there's out on the fringe. There's lots of people who have bigger ideas, but they're forced to stay on the fringe. They don't get the traction. They don't attract money. It's not like somebody says, oh, that's great. Here's $5 million. Let's do some really good research on this, because that takes money. It takes resources and places and people and equipment and lots of things. But that doesn't happen. Instead of the science looking where interesting things are going on that are different, it hasn't worked that way, which is a shame. So, Rupert, thank you for being a real scientist and, looking into things that need looking into. And shame on you, Ted, for, becoming part of the problem and kind of making sure that what you stand for doesn't happen. That is unfortunate. But, there've been people in the margins like this for a long, long time. This is not anything new. The people in the margins trying to get an audience and being pushed out by the by the trolls has been going on for centuries. It was going on for centuries back when the trolls were religious trolls pushing out Copernicus and Galileo and others. Even Newton had to walk a very tight path, or lest he got in trouble with the church.
Well, Galileo was pardoned after 500 years, so maybe, maybe it'll take a little while.
Yeah, well, maybe,
I don't know.
yeah, maybe Rupert's video will get put back on TED Talks in 500 years. Yeah, well, let's hope that it doesn't take that long. But
let's hope not.
Yeah, so I think, and all of Rupert's 10 ideas, I agree with him. These are areas where science is blindsided by their own beliefs, and that means they are areas that should attract real scientists, but they don't really, because real scientists, it's a job, and you have to make money, and you have to get research grants, and you don't do that by doing things that are off the beaten path. You do that by towing the materialist line. So that's the bigger problem. But hey, things are changing, and more of this gets out. Like you say, we're going to drag the scientists kicking and screaming, by their feet, right, into the 21st century. Eventually, they will have to get there, because all of their experiments now are saying virtual reality. Reality is information, and it's so overwhelming that they are even getting on board the virtual reality's information train. But then they still hit the denial, as far as that has anything at all to do with consciousness or means anything at all about the reality being bigger than the physical reality. I mean, I saw a bunch of PhD physicists sit around, and one of them was Edward Fredkin. One of them was Edward Fredkin. And Edward Fredkin, and they were discussing virtual reality. And all the physicists there thought virtual reality was a good idea and that reality was information. So they had gotten on board with that. And Edward Fredkin said, well, guys, a virtual reality can't compute itself. It has to be computed in other. A virtual reality doesn't compute itself. It can't get going that way. It didn't exist to start itself. You see, it's a problem, and And these other 4 or 5 physicists who all thought virtual reality was a good idea, they said, well, no, I don't agree with that. And then they changed the subject.
Yeah.
It was just flat out denial because they didn't want to go there.
I think one physicist from Germany perhaps
Yes, he
had a little bit of agreement. Jürgen.
Yeah, he
I
did.
can't remember the last
He said, and when we do figure this out, it's going to be simple.
Yeah.
He says it's just going to be simple ideas. But none of them would even go so far as to say what is trivially, logically obvious, which is a virtual reality cannot compute itself. And they were stuck there. So you see that even though science is now embracing virtual reality, reality is information, that doesn't mean that they're going to embrace the next paradigm shift, which is it has to come from outside of this physical reality. It has to come from outside of physical reality. And then the next paradigm shift after that is consciousness is the computer. Okay? And if they, so they got at least two paradigm shifts before they get there. And then after they find out consciousness is a computer, the next thing they have to realize is that the purpose that's driving all of this consciousness evolution is low entropy, which equates to becoming love. And that's also scientifically derivable too, but we won't take the time to do it there. And then that's the last thing. And if they ever get that far, that's 3 paradigm shifts, then we will be on a road to recovery. And our world should get a lot gentler and kinder after that. But we've got 3 major paradigm shifts to get through. And right now, the scientific establishment has their back to the wall, denying everything they see, that and banning heretics and so on. They're still fighting. But eventually, when everybody gets it but them, they will relent. But then the very next paradigm is that, okay, it's a virtual reality, but don't tell me about other, I don't want to go there. And then maybe 50 years after that, it's okay, other, but don't tell me consciousness, I don't want to go there. So we're going to have to drag them kicking and screaming from one, paradigm shift to the next, I'm afraid. But, the truth is the truth, and the truth is not fragile, and eventually we will get there because it's better physics and better science, and it is the way the world works. So that's the good news.
Thank you so much, Tom, and thank you too, Dr. Sheldrake.
Yes.
This has been very, very interesting.
Well, thank you, Donna, and thank you, Rupert. I'm glad that you decided to do this. It's been fun.
It has been very, very good. Thanks again, Tom.